Hello and welcome to our lesson on adding and subtracting rational expressions with common denominators. So we've talked about rational expressions being fractions of polynomials, and we've looked at two operations, the multiplication and division, and now it's time to move on to the addition and subtraction so that we can cover all of our bases. Good news and bad news. Adding and subtracting is going to be more difficult than multiplying and dividing, because when you add and subtract, you have to have common denominators. Okay, that's the bad news. The good news is today we're already going to have common denominators. And I may have mentioned what's helpful to realize here when you're dealing with rational expressions is the same rules that apply to just normal fractions that don't have polynomials. Those rules apply here when we do have polynomials. So adding and subtracting fractions, multiplying and dividing fractions, normal fractions, the same rules apply there as do for rational expressions. Okay? So we're already going to have common denominators for the fractions we're going to look at today. So what is the rule for adding and subtracting normal fractions? If we already have common denominators, for instance, if I said to add 1/8 with 5/8, well, when we already have common denominators, then we keep the common denominator. All we have to do is perform the operation here with the numerators. So if we're adding, we add the numerators. If we're subtracting, we subtract the numerators. So in this case, the 1 plus the 5 makes 6 in our 1 numerator. So we'll add or subtract our numerators. We're going to keep our common denominator, and then we're left with just one fraction that we can simplify. And this fraction we know reduces. If we divide the top by 2, we get 3. If we divide the bottom by 2, we get 4. And that would be our simplified fraction. So we're going to add or subtract our numerators. We're going to keep that common denominator. And we're going to simplify. In this case, we're reducing the one fraction that's left over. Okay, now when we apply it to rational expressions, the numerators could contain polynomials. So you have numerators that could contain terms like 3x to the fourth, or x squared, or 3x plus 1, 5x plus 3. So when we go to add or subtract those terms, we have to make sure that we're only combining the like terms. So when we apply this process to rational expressions, we want to combine the like terms from the numerators, and we have to make sure that if it's a subtraction problem, that we distribute that negative to all of the terms in the fraction that follow the negative. So be sure to distribute the negative if it's a subtraction problem, and I'll show you those in a little bit. Again, we're going to be keeping our common denominator, but once we've added or subtracted, we're going to be left with one fraction, and we're going to try to simplify the one fraction. And when we simplify, that could mean two things. It could mean reduce if all of the terms in the fraction have something in common, but it could also mean that we have to factor in order to reduce. Okay, so here are some examples involving just addition. We already have a common denominator here, so again we're going to keep our common denominator of 2x to the 7th, and we're going to try to add, that's just straight combine like terms from our numerators. So I know I can put together in this case the x to the 4th and 3x to the 4th. If I have 1x to the 4th and I add 3 more, that's going to give me 4x to the 4th. And then the second term here, the x squared, I can't actually add. It's not a like term with anything else. So I'm just going to bring that positive x squared over. And now I'm left with one fraction to simplify. And this one fraction can be reduced. All three of the terms have an x squared in common. So I'm going to divide all three of them by that x squared. And so 4x to the 4th divided by an x squared, remember when we divide, those exponents get subtracted out. That's going to leave me a 4x squared, right? 4 minus 2 is 2. And then x squared divided by x squared will just be 1. Or the 1 divided by 1 is 1, and then 2 minus 2 for the exponents will leave me 0 x's. So it's going to be a 1 there. And then on the bottom, 2x to the 7th divided by x squared is going to be a 2x to the 5th left over. And that's going to be it. The three terms in this fraction have nothing in common. We can't factor, so that's our answer. Okay? Alright, let's try again. So here we're trying to add these two fractions. We've got a common denominator. We're going to keep our common denominator, and then we're going to try to combine like terms from the numerator. This time we have some like terms. I can combine the 3x and the 5x. 3x is there, plus 5 more x's give me gives me 8 x's to bring over, and I can combine the constants. The positive 1 and the positive 3 gives me a positive 4 to bring over. And now again I'm left with one fraction to simplify, and this fraction can be reduced by 4. All three of the terms in the fraction are divisible by 4, or they have a GCF of 4. So I can reduce this by dividing each of these things by 4. So 8x divided by 4 is going to be 2x. 4 divided by 4 is going to be a positive 1, and then on the bottom again 4 divided by 4 is 1. Now you can leave it like that. The 1 on the bottom though is not necessary, so we're just going to make this a 2x plus 1 because division by 1 changes nothing. So either 1 would be fine, but the 1 on the bottom is just not necessary. Okay? Alright, how about this guy? Again, we've got a common denominator, so let's keep that common denominator, x plus 4, and we're going to try to combine like terms from the numerator. And let's see, we've got an x squared here. Nothing else has an x squared, so I can't combine anything with that x squared, which means it's just going to come over. And then I want to be in descending order, so even though the positive 3 is next, I'm going to jump to this term that has an x to the first, and nothing else in the numerators has an x to the first, so I'm just going to bring that positive x to the first over. The only terms I can actually combine here are the positive 3 and the negative 15, and positive 3 minus 15 leaves me a negative 12. Okay, now this fraction is not reducible. The 1, 2, 3, 4, 5 terms have nothing in common. They don't all have an x, they don't all reduce by a 4, and so I cannot reduce this fraction yet. Although you can factor on the top, right? Hopefully you're seeing you can factor on the top. In the numerator, if we multiply 1 and negative 12, we get negative 12, and we can definitely find factors that add to the positive 1 in the middle. Those factors would be 4 and negative 3, and dividing by 1, we're going to see that the top of the fraction is going to factor into a 1x plus 4 and a 1x minus 3. Which is nice because now we've got an x plus 4 in common to our numerator and denominator. So now we can reduce out the common binomial, the x plus 4, and that's going to leave us an x minus 3 for our final answer. Okay? So not so bad addition. I think it's going to be a little easier to handle than the subtraction, and we already have common denominators, so this isn't so bad. If you're feeling confident, this would be a good place for you to pause the video and try this out. If not, let's see. We're going to keep our common denominator, x plus 1 and x plus 5, and we're going to combine like terms from our numerators. So I have this x squared, nothing to combine with it, so x squared is going to come down. And then I have a negative 5x and a negative 3x, which are going to give me negative 8x altogether. And then I have a negative 9, nothing to combine with it, so that minus 9 is going to come down. Now again, this fraction is not reducible, but the numerator is definitely factorable. So if we look for factors in our numerator of, let's see, factors of negative 9 that are going to make negative 8, we can use negative 9 and 1. And dividing by 1 there, we see that our numerator is going to factor into 1x minus 9 and 1x plus 1. And then if our denominator still has an x plus 1 and an x plus 5, that means that we can reduce out an x plus 1 from each, right? That common binomial of x plus 1 gets reduced. So that reducing leaves us our final answer, which is an x minus 9 in the numerator and an x plus 5 in our denominator. And that is it. Now, just be careful. Some of you may be tempted to try to reduce x's here. Remember, if we want to reduce a fraction, all of the terms have to have something in common. Now these two terms have an x, but these don't. So if all 4 terms don't have an x, I cannot reduce an x. Okay? So make sure you're not getting ahead of yourself and reducing when you cannot. Okay? So far so good, hopefully. Let's look at some subtraction problems next. Subtraction, we have to be a little more careful because we have multiple terms in our numerators that we may have to subtract. So when we see subtraction, we are subtracting this entire fraction. So I need to make sure that that subtraction applies to the 4x and to the 30. All right, so we have to, when we see the subtraction, we have to distribute the negative. So if we distribute the negative, what happens is we can change this to a positive if when we distribute the negative, sorry, I meant to go eraser there. If we distribute the negative here and here, then we can just combine like terms. So when the negative gets distributed, basically we're going to change all of the signs. We can, if we distribute the negative, say, okay, afterwards we're just going to add, but it would become a negative 4x and a negative 30. So distributing a negative just changes all the signs, which is how I like to just go about this. So I'm going to change this to a positive, make this a negative 4x, make this a negative 30, and now we're just combining like terms. Okay, so distributing the negative is going to change all the signs. So we're going to keep our common denominator, x plus 5, and then try to combine like terms from our numerators. So I have this x squared, but nothing to combine with it, so x squared can come over. I can combine the 3x's here and the negative 4x's here, and 3 minus 4 is going to give me a negative 1x, and then I have this minus 30, nothing to combine with it, so the negative 30 will just come over. Now again, I have 1, 2, 3, 4, 5 terms in my remaining fraction that cannot be reduced. They do not all have something in common, but I can factor. So if I factor in my numerator, factors of negative 30 that make negative 1 would be negative 6 and 5. Dividing by 1, I see 1x minus 6 and 1x plus 5 will be my factors. So again, 1x minus 6 and 1x plus 5 in my numerator. And in my denominator, I still have the common denominator, which was x plus 5. And now we're good because we've got an x plus 5 in common to our numerator and denominator. So the resulting answer is the x minus 6 that is left over in our numerator. Okay? So just be careful with the subtraction. Make sure the negative gets distributed. So the same thing's going to happen here. If I distribute the negative, then I'm just going to combine like terms. So make this a positive, and then make this a negative 4x and a positive 3. So we're going to keep our common denominator. We're going to keep our x squared minus 1, and then combine like terms from the numerator. So I have 1x. If I take away these 4 x's, the 1 minus the 4 is going to give me negative 3 x's. And then I have this positive 3 to bring over, nothing to combine with it, so plus 3. Now I've got 4 terms remaining in this fraction. The 4 terms have nothing in common. These two have an x, but these two don't. And these two have a 3, but these two don't. So not reducible, but definitely factorable. So let's try to factor in order to reduce. In the numerator, we've got a GCF. The GCF, we're going to make a negative 3. Remember, when the first term's negative, make the GCF negative. So the negative 3 comes out. And dividing that out is going to leave us an x and a minus 1. And then on the bottom, we have a difference of squares. Oops, I wanted not the highlighter, but the pen. Okay, so the difference of squares, this is a result of x squared and 1 squared. So the bottom is going to factor into these conjugates, right? X plus 1 and x minus 1. Which means now we can reduce an x minus 1 from our numerator and denominator. So that leaves us a negative 3 in the numerator and an x plus 1 in the denominator. And those 3 remaining terms have nothing left in common, which makes that our final answer. Okay? All right, number 6 here. Looks fun. We've got 3 fractions, some addition and subtraction. Looks maybe a little intimidating, but it's not so bad. We've got common denominators, so we're going to keep that common denominator, x squared minus x minus 12, and try to combine like terms from our numerators. Now, before we combine like terms, if there's a negative, let's distribute it. So let's change this to a negative 4x, change this to a minus 7, and now we can combine our like terms. So I have 6x's here, minus 4 here, plus 1 here. 6 minus 4 is 2, and then 2 plus the 1 gives me 3 x's to bring over. And then, let's see, we have a negative 7 here and a negative 5 here, which gives me a negative 12 to bring over. Now again, you might be tempted to reduce this fraction. You might be tempted to say, oh, those cancel. No, guys, please don't do that. We have 1, 2, 3, 4, 5 terms in this fraction. All 5 of them don't have a 12. All 5 of them don't have an x. All 5 of them have nothing in common. So this fraction cannot be reduced yet. Okay, it can be factored, however. Again, we have a GCF in the top. The GCF this time is a positive 3. So if we factor out that positive 3, that's going to leave us an x minus 4. And then in the denominator, we can find factors of negative 12 that make negative 1. And those factors would be a negative 4 and a positive 3. And dividing by 1, we can see we're going to factor into 1x minus 4 and 1x plus 3. And now we've got a common x minus 4 that we can reduce. So that's going to leave us a 3 in the numerator and an x plus 3 in the denominator. And again, you might be tempted to reduce, okay, but we cannot do that. How many terms do we have in this fraction? 1, 2, 3. Do they all have a 3? They do not. Okay, so we cannot go any further. Don't you do it. Okay, I know it's tempting, but this is going to be the final result. Okay, again, if you're feeling good about this, I've got one last problem, so feel free to pause the video and give it a try. Otherwise, let's get this done. Let's see. Keeping our common denominator, x squared minus 9. Before we combine like terms, this is a negative, this is a subtract, so let's distribute it. Let's make that a negative x and a negative 12. So we can put together the negative 3x and the negative 1x to give us negative 4x's here. And then we have a minus 12, nothing to combine with that, so we're just going to bring that minus 12 over. And now we can factor. We've got a GCF in the numerator of a negative 4. So if we factor that negative 4 out, we're going to be left with x plus 3. And then in the denominator, again, a difference of squares. This is the result of x squared and 3 squared. So it's going to factor into the conjugates, x plus 3 and x minus 3, and now our numerator and denominator have an x plus 3 in common. So we reduce that common binomial out, and that leaves us a negative 4 over an x minus 3. Nothing left in common, nothing left to, nothing left to factor, which means negative 4 over x minus 3 is our final answer. Okay, so there it is. Hopefully that was somewhat manageable. When our fractions already have common denominators, we're in good shape. When they don't, we're going to obviously have to get common denominators, but that's something that we will look at in the next couple of topics. So for now, if you got some practice, try it out, and as always, if you need some extra help, just reach out. Alright guys, take care.